Alright, this is Mr. Gilman. Today we're going to learn about angles of elevation and depression. An angle of elevation is the angle formed by a horizontal line in an observer's line of sight to an object above the horizontal line. So today there's going to be a lot of word problems. It's going to say, oh, you're looking here and this is what's happening. Okay, you just need to be able to identify the difference between angle of elevation and angle of depression. Angle of depression is the angle formed by a horizontal line in an observer's line of sight to an object below the horizontal line. Okay, and so I have a little diagram here, and what I want you to notice is if this is the guy looking down, we would have an angle of depression with a horizontal line here and the angle in which he's looking down. If we were looking at this little guy, it would be an angle of elevation if he's looking up at this guy. So the angle of elevation would be right here. And because they're both horizontal lines, we know they're parallel. So what you can say is the angle of depression and the angle of elevation are congruent. They're alternate interior angles. Okay? So I guess what you could write down on your paper is angle of elevation is equal to the angle of depression. And that's because alternate interior angles theorem. Okay? These are horizontal lines, these dashed lines. That means they're parallel. You have two interior angles, alternate interior angles. They must be congruent. So that's a good thing to keep in mind for today. And if you just think about the word depression, the word elevation, it would make sense that elevation is the one when you're looking up and depression is the one when you're looking down. So let's take a look at an example here. It says, Leah is meeting friends at the castle in the center of an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. So before I even read anything else, I'm going to start drawing a picture here. Here's Leah. Okay. Smiley. Okay. And what she sights is the top of the castle. Okay, there's my castle. And there's an angle of elevation there at 38 degrees. So when she's looking at the top of the castle right there. And there's this, don't forget, there's this horizontal line right here. And the angle of elevation is 38 degrees. Okay. From the park's brochure, she knows the castle is 190 feet tall. So I know from the top to the bottom of the castle, it's 190 feet. Leah is 5.5 feet tall. About how far is she from the castle to the nearest foot? We're going to assume her eyeballs are at the very top of her head for this problem. So what I have here is a right triangle. I know it's a right triangle because this is a perfectly horizontal line. And we're assuming, of course, that the castle is directly straight up and down. And what it's asking us is about how far from the castle to the nearest foot. So what we need to know is this distance here. Okay? If Leah is 5.5 feet tall and the entire castle is 190 feet tall, that tells me that in my right triangle here that this opposite side of 38 is really 184.5 feet. Okay, so the distance from here to here is 184.5 feet. If I'm looking for the unknown, now I'm just going to use my trig functions to solve for it. It appears that I have an angle of 38, an opposite side, and an adjacent side. So I'm going to say that the tangent of 38 degrees must equal the opposite, 184.5, divided by the adjacent side, x. And now it's a matter of solving. So if I make it look like a proportion, I can cross multiply x times the tangent of 38 equals 184.5, and then I'm just solving for x by dividing that tangent of 38. Remember, tangent of 38 is just a number. Okay, it's best if you leave it as tangent of 38 as long as you can until the last step, so you have the most accurate answer. When I divide 184.5 0.5 by the tangent of 38, I get 236. 1492311, but it does say about how far is she from the castle to the nearest foot. So we're going to say that she's about 236 feet away. All right. So we're just using the trig. That's just a matter of setting up the picture properly to make sure you have everything in the right spot. Take a look at the one where we're going to use an angle of depression. This problem says that a search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression to the other person is 42 degrees and the helicopter is 18 feet above the water, what is the horizontal distance to the rescuer's person to the nearest foot? Okay, so looks like we have a helicopter here. Helicopter looks something like that. Perfect. And what they're doing is they're looking down onto this person that's on the water. He's still smiling, even though there's a shark here. Okay. Okay, if the angle of depression to the other person is 42 degrees and the helicopter is 18 feet above the water, so let's go ahead and get that in there. There's 18 feet right there. And the angle of depression, so it's the angle formed with a horizontal line and the person here. This angle is 42 degrees. What is the horizontal distance from the rescuer to this person to the nearest foot? So we're looking for this distance. Okay, so I'm going to call him X. Remember, on the diagram earlier we said that because this is horizontal and this is horizontal, they're parallel. The angle of depression and the angle of elevation from the person looking up to the helicopter are the same angle. I'm going to go ahead and put that 42 degrees down there where he's looking up as well. Okay, it's the same, it's congruent angles. So what I have again here is I have 42 and I have an opposite side of this right triangle and I have the adjacent side of this right triangle. So again, I'm going to use the tangent function. The tangent of 42 equals 18 over x. And again, I'm going to set it up as a proportion. And I'm going to cross multiply. X times the tangent of 42 equals 18. And I'm going to divide by the tangent of 42. And yes, this is a shark right here. I'm going to eat the person if we don't get there soon. Anyway, 18 divided by the tangent of 42. Looks like about 19.99. 102572527. Just if you're following along with your calculator, I got all those numbers on there, but it does say to the nearest foot. So we would say approximately 20 feet away. Let's take a look at the next one here. It's also an angle of elevation, but it's actually a system that we're going to have to solve. It says to estimate the height of a tree she wants to remove, Ms. Long sights the top of the tree at 70-degree angle of elevation. So originally she's standing here and she's looking up at the tree. Then she steps back 10 meters, so that represents this length here, and she sights it again, but now it's only a 26 degree. If Ms. Long's line of sight is 1.7 meters above the ground, how tall is the nearest to the nearest meter is the tree? So there's a 1.7 there. Now, unfortunately, we have two unknowns in this problem. So what we need to do is we need to have two equations. Two equations and two unknowns are solvable. So what I see here is I see a big right triangle and a smaller right triangle, but I see that I could use the tangent to have both variables in each equation. So I'm going to set up my equation. The tangent of 26 equals x over y, and the tangent of 70 equals, the tangent of 26 should equal x over y plus 10. and the tangent of 70 equals x over y. And I don't recommend you do this. I prefer you to keep the tangent all together, but because we haven't done a lot with systems this year, I'm just going to go ahead and change the tangents to decimals so it's a little more familiar. I'm going to change this tangent of 26. It's just going to be an estimation to 0.49 equals x over y plus 10. And I'm going to change the tangent of 70 to 2.75 equals x over y. And I think that's just going to help us to solve these without having the tangent confusion in there. So let's go ahead and solve for x in both equations. To get x by itself, I'm going to multiply both sides by y plus 10. And this 0.49 is going to be distributed. So I have 0.49y plus 4.9 equals x. And on this one, I'm going to cross multiply as well. I have 2.75y equals x. And so now I have, oops, I forgot the y on that one. There we go. Now I have these two equations with two variables. I can start substituting. So let's go ahead and substitute in for this x, this 2.75y. Say 0.49y plus 4.9 equals 2.75y. I'm taking out this x and I'm putting in what it's worth. And now it's just going to be a matter of getting all the y's together. So I'm going to subtract 0.49y from both sides. 4.9, 0.49. So I have 4.9 equals 2.26y. And then I just continue to solve for y. 4.9 divided by 2.26 is 2.17. And I can use that information to solve for x. So I'm going to say 2.75 times 2.17 equals x. I'm just plugging in this information for x. And so I have 2.75 times 2.17, 5.97. X equals 5.97. So what I really have here is the height of the tree from here to here is 5.97. And we're dealing with meters. And I have y is 2.17 meters. So what it asks us is how tall is the tree to the nearest meter? Well, I have this 5.97, but I have another 1.7 meters worth of height from here to here, which is also on top of the tree. So I really have 5.97 plus 1.7 for my total. Now I get 7.7 meters. So to the nearest meter, what we really have is about 8 meters. So we're going to say the tree is about 8 meters tall. So let's go ahead and do the last example in class. And that's it for today.